You've probably heard the saying, what you can't measure, you can't manage. Well, today we are cracking open the consultant's playbook to pull out a seriously powerful tool, the X-bar R chart. We're not talking about some abstract theory here. This is all about gaining real statistical control over your operations so you can finally understand what's really going on inside your business.
So let me ask you this, and be honest. Is your process actually stable, or have you just been getting lucky? It's a question every sharp manager has to face. See, when you have unmanaged variation, you get unpredictability, you get inconsistent quality, and that leads straight to unhappy customers and rising costs. The real game changer, what separates the best from the rest, is knowing the difference between just random everyday noise and a critical signal that's screaming for your attention. All right, here's our game plan. First, we'll tackle the core problem itself, process variation. Then, I'll introduce you to your new best friend, the X-bar R chart. We'll go over the rules for using it correctly, walk step by step through a real-world playbook, and then wrap up with the critical principles you absolutely need to know for success.
Okay, let's dive in. Every single process. I don't care if it's on a factory floor, in a software development cycle, or at a coffee shop, they all face the same fundamental challenge: variation.
Look, every process has a natural rhythm, right? Some minor ups and downs. We call that common cause variation. It's just background noise. Now, the single most expensive mistake managers make is something called tampering. That's when they react to that noise. They start fiddling with the dials of a perfectly stable system, and ironically, they just make things worse. Our job isn't to get rid of the noise. Our job is to hunt for the special cause variation. Those are the signals. Those are the outliers telling you that something important has changed and you need to step in and act. So, the big question is, how do we separate that critical signal from all the noise? Well, this is where our tool comes into play. The X-bar R chart is this brilliant two-part diagnostic that gives us a crystal clear window into the health of any process. The first part is the X-bar chart. Now, X-bar is just a fancy way of saying the average. This chart plots the average of small samples, or what we call subgroups, over time. It tells us if the center of our process is stable. Think of it like you're at a shooting range. The X-bar chart tells you if, on average, your shots are hitting the bullseye. And the second part is the R chart. R here stands for range. You know, the difference between the highest and lowest value in each of those little samples. This chart doesn't care about the average. It tracks the spread, the consistency of your process. Back to our shooting range analogy, the R chart tells us how tight your shot group is. You see, you could be centered perfectly on average, but if your shots are spread all over the target, you still got a huge problem with predictability. Now, it's really important to get this. The X-bar R chart is a specialized tool. You gotta know when to use it. It's your go-to when you're collecting data in small groups. The rule of thumb is between 2 and 10 samples at a time. If you're just looking at individual data points one by one, you'd use a different tool, like an IMR chart. And for bigger sample sizes, you'd move on to an X-bar S chart. Honestly, choosing the right tool for the job is half the battle. Okay, having the tool is one thing, but using it right, that's everything. So let's talk about the rules of engagement, because believe me, misreading these charts can lead to some seriously costly mistakes. This right here is the golden rule. It is non-negotiable. You always look at the R chart first, always. And here's why. The control limits on your X-bar chart, the lines that tell you if you're in or out of control, they are calculated directly from the data on your R chart. So if your process variation, your R chart, is out of control and all over the place, then those control limits on your X-bar chart are completely meaningless. They're fiction. You have to get the spread of your process under control before you can even think about judging the average. Theory is great, but at the end of the day, results are what matter. So let's roll up our sleeves and walk through a real-world implementation playbook. We're going to use a case study from a manufacturing process where the thickness of a metal plate was absolutely critical. We're going to follow a really simple 5-step plan. First, we'll define our objective. Then, we'll compute the values we need. Third, we'll determine the control limits. Fourth, we'll interpret that initial before state. And finally, we'll monitor the process in the after state to see our improvement. So here's the situation. The process for making these plates was officially not capable. Now, that's just a technical way of saying it was consistently failing to meet the customer's requirements. So the project team jumped in to investigate. They did it systematically. They collected 20 sets of samples, and in each set, they measured 4 plates.
And that subgroup size of 4, it's right in the sweet spot for an XBAR R chart.
Now, a crucial point. These control limits we keep talking about, they are not just random guesses. They're calculated directly from your own data using standard statistical constants like the ones you see here. In our case study, the team's subgroup size, or N, was 4. So you just go to this table, look at the row for 4, and pull these specific numbers, A2, D3, and D4, to build your charts. No magic, just math.
So the team took their initial data and plotted it. And wow, the result was undeniable. This quote from the source material says it all. The before charts were a total mess. You had points flying way outside the control limits on both the R chart and the XBAR chart. This wasn't just noise, folks. This was a clear signal. The process was fundamentally unstable, and it was screaming for help. So the team got to work. They identified and fixed those special causes of variation. Then they kept monitoring the process. And look at the difference. The after charts tell this incredible story of improvement. The data points are behaving themselves now, falling almost entirely inside the control limits. They took that chaotic process and brought it into a state of statistical control. It's now stable, it's predictable. That is the power of this tool right there.
You know, getting a process into control is a huge win, but keeping it there, that takes discipline. To really make this tool work for you, there are a few critical principles you have to internalize. These will help you avoid some very common and very costly pitfalls. Okay, let's lock in 4 key principles. Number 1, in control just means stable and predictable. It doesn't mean your process is perfect or even good. It just means its variation is consistent. 2, think of these charts as your shield against tampering. They give you statistical proof that you should leave the process alone. 3, never forget that you are charting the averages of small groups, not individual measurements. That's a huge distinction. And 4, and this is a big one, you can only study process capability, whether you can meet customer specs, after you have proven the process is stable and in control. An unstable process, by definition, has 0 capability.
All right, if you remember nothing else from our time together today, please remember this. Never, ever put customer specification limits on a control chart. It is the single biggest mistake people make. Why? Because your control limits, that's the voice of your process. They tell you what the process is actually capable of doing. Specification limits, that's the voice of your customer. That's what you want the process to do. Mixing them up on the same chart causes massive confusion and leads to terrible decisions. They are 2 different tools that answer 2 very different questions.
So we've seen how this tool can take an unstable, unpredictable process and turn it into something stable and manageable. It gives you a clear, data-driven language to understand and improve performance. So I'll just leave you with this one question to think about. What critical process in your organization, on your team, in your own work is currently just running on luck? What process could you bring under statistical control, starting today?